Hi students, today class we are going to discuss about a new topic, that is optical encoders. So this is nothing but it's a electromechanical device that provides a feedback information in a closed loop motion control system. So it provides the information in a closed loop motion control system in terms of position, velocity, and their direction. Okay, so it provides these kind of information in any kind of motion control system. That is the main role of optical encoders. Okay, so it provide information for both a mechanism of rotatory and linear mechanism. Here I have given example for rotatory mechanism. Here this example for linear mechanism. Okay, uh, then what type of information it can provide? It can provide information in terms of direction, position, and velocity. So if you take direction means in for rotatory mechanism, either you can have clockwise rotation or anti-clockwise rotation, right? So this represents the direction. For linear, either it can have the direction towards right side or towards the left side. Okay. So this is all about the direction. Next, if you're pointing on position, okay, if you want to know what is the position for that respective motion control system in the sense, yeah, you have two way of measuring, or in terms of for rotatory mechanism, you will be measuring in terms of a degree. Okay, degrees, that is from 0 to 360 degrees. From this what is the exact position? For example, the this motor is in 270 degree. It means that it is representing the location, that is the position of the rotor. Okay, similarly if you have position for a linear mechanism also, that is you have, for example, here I have given inches, that is 0 to 15 inches total measurement. So where is the shaft is located, like it is in a fifth inches or 10th inches, like that you can point out where the exact location is it is. Okay, this is all about, it's giving information about the position. Okay, and last one is what? Velocity. So velocity is nothing but the speed of the particular system. Okay, so here the given example is motor. So motor will rotate at a particular speed, right? So that is the rotation per minute. So it will start from 0 to 60. So what is the velocity of that motor? If you are providing information of that, then you can easily identify what is the velocity of the motor. Similarly, for linear velocity, you can have example is escalator. So escalator will move slowly, right? At particular velocity, it will move from one place to another in linear arrangement. So that is the example for linear mechanism. So here the thing is, it's giving the information about velocity. So optical encoders is all about, it's giving information, provide the information about velocity, speed, and direction of any motion control system. Okay, so let's see the components of optical encoders. The optical encoders have four major elements. One is light source. This is the light source, and if you have light source, then obviously you should have some detector, light detector, that is called light sensor. Okay, so next in between light source and light sensor, you have a optical disc, that is the third part, and fourth part you have a signal conditioning circuit. Okay, so output of the signal conditioning circuit is always carries the information about what you need, what you demand, like whether about velocity or speed or direction. Okay, so this is the main four parts of optical encoders. Let's see each one by one. First, light source. The light source is nothing but here we can use a light emitting diode. Here this diode will emit the light. Okay, there is a light emitting diode we are using here. So especially we have a number of light source, even infrared, visible light, UV light, like that we have a number. But here in optical encoders, they preferably use the infrared light for the mechanism. Okay, so light source is the LED light. This LED light which is emitting the infrared light, which acts as a light source here. Next, we will have a light sensor. So here they have taken phototransistor as a light sensor, that is the light detector. So that incoming light will be detected or sensed by this phototransistor, and then it converted into equivalent voltage signal, equivalent output signal. That is the main role of light sensor here. Okay, so phototransistor, you know what is light. So here this is it has it having the working principle of both combination of photodiode plus transistor. Okay, so that is the phototransistor. Just you have three terminals, base, collector, emitter, that you know already. So if there is any instant light on the transistor will get phototransistor, the phototransistor will get activated, so that irrespective you will be having the current generator. Okay, current generation, there is a phase current, so you can have at collector and also the emitter. So when you measure the voltage drop across these two, you can get what is the output over here. Okay, that output is directly proportional to the amount of light which is incident on the base terminal of the transistor. So this is the generalized mechanism of phototransistor. Okay, next is optical disc. So this is the optical disc. Where it's located, it is located between light source and light source and a light emitter, that is, sorry, light detector, that is a light sensor. Okay, so this is the place between light source and light sensor, and mainly this optical disc is connected to the shaft. This is the sensing element which is being measured. Okay, the shaft rotation or shaft, the direction of the shaft, the velocity of the shaft, and position of the shaft only, here the thing we are going to measure. Okay, so the optical disc is where it is connected, it is being connected to the shaft which is being measured here. So it is very important, so that the disc and shaft can rotate together, by means of that we can measure what is the information which is related to this. Okay, so then as this optical disc, okay, this optical disc has been designed in such a way to have both things. One is open slots, that is also called transparent slots. This is the opening slot through which the light can easily pass through, and it also contains the opaque areas that is placed between two opening slots. These opaque areas will reflect the light source. Okay, so it has been placed alternately. In this way, this optical disc has been designed. Okay, so the optical disc have two parts. One is opening transparent slot, through which opening the light can pass without any disturbance and reach the light detectors. Whereas other between each two opening slot, you have a space, that is opaque area, where the light will not pass. It is keep on reflecting, so that the light from the light source will not reach the light sensor. This is the arrangement you can see in optical disc. Okay, so as the disc is rotated, what will happen now? The light will alternately pass through the transparent slot, that is opening slot, and it can also alternately blocked by the opaque areas which is placed between the slots. So you have a light passage at next light off, then again you have light on, and again you light off. So in this manner, alternately you will be having the passage of light, that is the reaching of the light to the sensor. Okay, so next, what is the next part? You have a signal conditioning circuit, right? So the output of the phototransducer now is connected to the schematic figure. Okay, and you have also the load resistor. Okay, and you have load resistor here. Let's see how the optical encoders is working. So now let's start when the light is present. That means when the light is passing through the opening slot and reaching the sensor. When this condition, what is happening? Let's see. Okay, so when light passes through the slot on the disc, the following condition is occur. What is in the sense? During this case, the transistor gets on, because the light is reaching the phototransistor, means obviously the phototransistor will get activated, so it's turned on. So once it gets turned on, there is a minimal resistance. Okay, so there is no obstructions over there, so that if there is a minimal resistance, the voltage drop across the transistor here will be 0. Okay, so since you are a collector here, this is the collector, this is the emitter, right? So that since the collector is directly connected to the input of the schematic trigger, the voltage drop, that is a 0 volt, is a volt which is generated at the collector transistor is fed to the input of the schematic trigger now. So which is obviously results in 0 volt potential even at the end of the schematic trigger as the output. Okay. So next you will be having the near 5 volts, that is from the power source. So you will be having the drop across the load resistor, that is the 5 volts. Now the thing is, you have to see the switch is on. so that your phototransistor is getting activated. The light is reach the phototransistor, so the phototransistor is get activated, so that you will having very minimum resistance, so that the voltage drop across the transistor is 0 volt. So 0 volt, since the collector current the collector terminal is connected to the input of schematic. So what is the voltage drop which you get across the transistor will be fed to the input of the input to the schematic, so that the output of the schematic also you get 0 volt. So when since it having the input as 0 volt, schematic will not activate, so the output also will get as a same 0 volt. Okay, this is the condition when the light passes through the slot. Next, second condition is if this light blocked. This is the condition when the light is blocked by the opaque area between the slots. This is the following condition will occur. Okay, so during this case, your transistor turns fully off because there is no light which to be reach transistor, so the transistor will not be getting activated, so it becomes off. Since it acts like a open since it's act like a open circuit, there will be a creation of large resistance. So voltage drop across the transistor will be near 5 volt, that is equal to the power source. Okay, so since now again the transistor's collector is fed to the input of the schematic, even the output of the schematic will also leads to what 5 volts at the end. Okay, and whereas near 0 volt is drop across the load resistor. But here the load resistor now turns into 0 volt. Since we are having a very large resistance here, we will be having the voltage drop of 5 volts. The output, the collector current and the collector side of the transistor is, since it connected to the input of the schematic, the 5 volt which is developed across the transistor, now it's given to the input of the schematic, so that output also you will get the 5 volts. So in two condition, one condition you will get 0 volt, another condition you get 5 volts. Other condition 0 volt, another condition is get 5 volt. So alternately you are having the voltage difference like is 0 volt, 5 volt, 0 volt, 5 volt, 0 volt. So at last you will get this kind of trine of pulse as the output of schematic. Okay, this will provide information about what is the exact position or what is the direction of the movement, or you can also have the velocity of the particular motion control system. Okay, so see, this is the schematic. So schematic role is it convert the pulse from the phototransistor into the square wave, which is required by the computing device that receive the feedback signal for closed loop system. Okay, so this is the output you will get from the phototransistor. From this output, you are keep on converting into the square trine pulse. Okay, so you know in photo schematic you need two things. Okay, you need two things. One is upper threshold, another one is lower threshold. For example, upper threshold is 5 volt and lower threshold is 0 volt in this 0 volt in the sense. Okay, sorry. Upper, you have two things. One is lower threshold, another one is upper threshold. For example, lower threshold is 0 volt and upper threshold is 5 volt. Okay, 5 5 volt. So if the output of the phototransistor will be like this 0, and then it will cross the upper 5 volt, and then again it turns into 0, and again it will cross into upper, again it will cross 0, then again it turns into reach the upper threshold, that is 5 volt. So this is how you will have the output of phototransistor. So how it's getting changed in schematic in the sense. So for 0 volt, the point where it reaches 0 volt, uh, it will represent in this manner like this. Okay, this is the represent of 0 volt. Okay, so then when this point crosses the upper threshold, immediately it will shook off like this, and it remains stay like this when again it crosses the upper threshold and try to reach when it try to reaches the lower threshold. Okay, then once it meets the upper threshold, again it goes down. Sorry, lower threshold again it goes down. So when it cross the upper threshold, again it it's get hike, and again when it reaches the lower threshold, again it's keep on down. So it will do like this. It will keep on generating the trine pulse of waveform like this, that is square trine pulse. Okay, this is the actual output of schematic. Okay, so from this square pulse we can get the output, what is the position and what is the direction of that optical encoder, sorry, what is the direction of the rotatory mechanism, whether it is a linear motion or rotation motion, and also we can measure the speed of or velocity of that particular mechanism. Okay, so that's all guys about optical encoders. Thank you.